So in the previous lecture, we discussed display filters. So what are display filters? Display filters are filters that you use when you want to focus on something in the output results. So all the results are there, but now you just want to see some specific protocol, maybe originating from specific IP, going to destination's IP or a specific port. But there's another type of filters which are called capture filters. Now, capture filters specify what do you want to capture in the first place. So the difference between these is that display filters come in action once the packets have already been captured or are being captured. However, capture filters come at the beginning. So you specify what do you want Wireshark to listen to or capture in the first place. And just like display filters, you can again filter based on protocols such as TCP, UDP, HTTP, DNS. You can capture on source and destination IP addresses. You can filter on specific source and destination port numbers, URLs, and so on. Now, one nice thing about capture filters is that they use the exact same syntax which we previously discussed for TCP dump. So basically all of these solutions, these tools, they use a standard which is called Berkeley Packet Filter or BCF, which is sort of like an industry-wide standard. So that's the nice thing. And all of the commands that you learned for TCP dump are going to work here as well. So for example, if you want to only capture traffic to or from going to a specific IP, you specify host IP address. Okay. So all of the traffic going to this IP or coming from this IP will be captured. Now only traffic from IP. So basically you want any traffic which is originating from this IP address. Okay. Source host 192.168.1.10. Only going to a particular IP address, destination host IP address. Only TCP traffic, TCP, only UDP traffic, UDP. And then obviously you can combine, for example, TCP traffic going to port 80 for web traffic. So this is common web traffic. And then only DNS, again, you'll be using UDP and port 53. From TCP and originating from source this, so you can use TCP and source host this IP address and port 443. So port 443 means either coming from port 443 or going to port 443. Similarly, just ping traffic, ICMP, and then obviously you can combine as always UDP traffic and destination host this one and destination port this one. So this would be, for example, a DNS query going to destination IP address 1.1.1 and destination port 53. So exactly what we did previously for TCP dump. So that's something nice to have. It's the same commands. Now let me go to Kali Linux and demo this. We are already running the lab, but just to be very sure, let's just rerun the lab once again so that we have everything set up. Okay, so we want Wireshark introduction lab. So once again, number 5. And Wireshark lab is ready to use. Okay, let me just clear the screen. So let me just stop this capture and let me remove the display filter. So this was all the traffic captured, okay? But now we want to capture specific traffic. So for example, once again, we'll pick as input Docker 0 interface. However, here you can see the capture filter for selected interfaces. What exactly do you want to capture? So let's say we want to say any traffic coming from Kali Linux VM. Okay, so we just want to capture that one. So source host 172.17.0.1. And then if you click start, Wireshark is going to start listening on interface Docker 0 and it's going to pick all the traffic coming from this IP address. So another interesting feature of Wireshark is that if you have previously captured some packets, so it will ask you, do you want to basically save all the captures or do you want to discard them? Let's discard them for now. But just so you know, even if you haven't specified originally any, saving file or capture file where you want to save results, you still have this option. So you can click save and then specify a file and all of the previously captured traffic which you were working on will be written to that file. Okay, in this case, let's just discard and continue. So once again, we'll create two different types of traffic. So first would be nmap and let's scan port 22. Okay, 172.17.0.2 and then let's just ping 172.17.0.2 and let me stop it. Okay, now as you can see here, we saw all of this traffic. Now you'll also see a bunch of other protocols, but we're not interested in those. There would be other traffic going on also sometimes. But let's focus on what we're discussing now. So in this case, the first traffic was TCP going from Kali Linux VM to Nginx container, and second one was ICMP traffic. But pay attention. Previously, when we saw this ICMP or ping traffic, we were able to see ping request as well as ping replies. But now we are just seeing ping requests. Why? Because we have specified that we just want this IP as the source. So the reply would have this IP as the source and this as the destination. So basically from Nginx container to Kali Linux, but that's not visible here. So that's how you can specify exactly what traffic do you want to capture. Let me demonstrate this once again. So let me stop this one and let's go back here and let's go Docker 0 and let's say now I just want to capture, for example, ICMP traffic. Okay. So now let's start it again. Continue without saving. And now let me send the TCP traffic or nmap scan once again and let's see if it's going to capture that or not. Okay. So you see there's nothing here. Okay, sometimes you may see some background traffic or ARP resolutions, but those are not relevant. And moreover, we have specified we just want ICMP protocol traffic. Okay, now it's just going to capture any traffic which is ICMP based, which is for example 172.17.0.2. There you go. It has started to capture all the ICMP traffic. So similarly, we can also specify just HTTP traffic going from Kali Linux VM to the Nginx container. Okay, so once again, what we are going to do is that we're going to go here. So let's say we just want to capture web traffic. So it will be TCP and source host 172.17.0.1 coming from Kali Linux VM and destination port, for example, 80. This is going to just capture TCP traffic, basically web traffic, coming from Kali Linux VM and going to destination port 80. You can also be more specific. You can add and destination host 172.17.0.2. But just to demonstrate and just make sure that you have picked the correct interface in the menu, just to be sure. There you go. So let's start. So now if I send ping traffic, okay, so let me clear the screen. Now if I just send ping traffic, for example, 15.0.2, there won't be anything. Similarly, even if I do nmap, there'll be nothing. But if I open the web browser and go to HTTP 172.17.0.2, then you're going to see all of this traffic once again. So once again, the key point is that in the capture filters, you specify what do you want Wireshark to capture. And then obviously you can still apply display filters as well. So for example, let me give you another example. Let's say you go here and you specify the capture filter to be, let's say TCP traffic, okay? Let's say all of the TCP traffic and we start listening. This is the capture filter. So now it's going to obviously basically capture all of the TCP traffic, including let's say nmap traffic, web browser traffic. This would be going to port 80. The other one was going to port 22. Nmap was going to port 22. And this one is going to port 80, for example. So let's say now you want to apply display filters. So you've already applied the capture filter, TCP, but now you also want to apply display filters, for example. Okay, one more thing is that I'm not seeing the web traffic. So let me just trigger that as well. 172.17.0.2 Nginx container. Okay, so now we have a healthy combination of traffic. Now let's say after applying this capture filter, I also want to basically apply a display filter, which we discussed last time, right? So here you can see basically the nmap traffic, which was this one, as well as the web traffic. Okay. Now let's say I just want to see the nmap traffic, in which case I know that this was once again TCP and destination port is equal to 22. Okay. Because I know that nmap scan, we only scan port 22. So there you go. And once again, you have all the headers and everything. So that's how capture filters and display filters make your life very easy. Now, having said that, generally what happens is that we don't specify very narrow or specific capture filters usually. So we like to capture a bunch of traffic going to different protocols because we sometimes don't know exactly what we want. Sometimes, yes, for example, if you want to just monitor traffic going to a particular server, for example, across an interface, then yes, you can specify just capture traffic going to that IP or coming from that IP, for example. But generally speaking, it's not very strict. So usually what we do is that in the industry, we do capture a bunch of traffic, maybe sometimes even all of the traffic. And then we apply display filters to narrow down. Because the reason is that the more information you can capture and maybe store it in a file, the more flexibility you'll have down the road of doing a forensic investigation. Sometimes you don't even know what exactly you will be looking for when something happens. So it's at the display filter side of things where we focus a lot.